All right, so for lesson 1-10, we're going to be using operations with numbers in scientific notation. So the objective is to apply number properties to calculations with numbers in scientific notation. So we're going to be adding, subtracting, multiplying, and dividing with numbers that are, again, in scientific notation. So we're going to start with when you're adding or subtracting. So for this first example, they give us the moon mass and they give us the earth mass, and I want to know how much greater is the mass of Earth than that of the moon. So one way that you can do this is to write them in expanded form, or standard form, my apologies, and see what they are and then subtract them from each other. Now the reason I'm using subtraction for this problem is because it wants to know how much greater it is. If it was asking how many times greater is it, then you would be using division to figure out how many times greater it is, but since it's asking how much greater, we're looking for the difference between the two. So let's start by taking the larger number, in this case the Earth's mass, and I'm going to write 5.97 times 10 to the 24th in standard form. So 5.97 times 10 to the 24th. You want to give yourself some room here because this number is going to be pretty large. So my decimal point was here. I'm going to move it 24 times. 1, 2, and then I'm going to have 22 more zeros here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. Okay, and then the moon mass, which is 7.35 times 10 to the 22, I'm going to be rewriting that in standard form. So that's the same as 735, and if I'm moving it 22 times, I'm going to move it 22 times to the right, so 1, 2, and then 20 more place values, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Now we need to line these up so that we can subtract them. So I'm going to line them up again by the zeros. So this one has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25 numbers in it, and this has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23 numbers. So when I line them up, this one is going to start essentially 2 more place values to the right, since it has 2 less numbers in it. So let's add on our zeros here. Again, we have 22 zeros here. And then I had 735 and then 20 zeros here. And you can already tell that this method here is going to be very inefficient, so I'm going to show you a different way that you can do this next that might take out some of this time. So you're going to notice that all these zeros are kind of cancel each other out, so when you subtract up to this point, sorry, not cancel each other out, but zeros minus 0 is 0. Here we're going to have to borrow, so I can subtract, and I end up with a very large number, 5, 8, 9, and then let's put some commas in here. Okay, and if I want to write this back in in scientific notation, I would have to again see how many times I need to move this decimal. So it's going to be, the decimal would fall here, So 5.8965 times 10 to the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24th power. So the Earth is 5.8965 times 10 to the 24th, much more bigger than the Moon. So lots of work here, lots of writing zeros, gets a little bit tedious. So I'm going to go ahead and show you the quicker way to do that, which is to write the masses using the same power of 10 and then subtract them. So we have 5.97 times 10 to the 24th, and we have 7.35 times 10 to the 22nd. We want to change them so that they both are written to the same power. So in this case, to the power that's less. So we're going to take the power of 22 and we're going to change 5.97 times 10 to the 24th to that number. So what I can do is pull out in this problem. I can change this to by moving this 2 more times to the right. I can change it to 597 times 10 to the 22nd power. So I basically got rid of 2 powers by adding on 2 more decimal places to my 5.97. Okay, so now I'm going to be subtracting 597 times 10 to the 22nd minus 7.35 times 10 to the 22nd. Now when you're subtracting numbers that have the same base, or sorry, the same power of 10 here, what you can do is subtract their numbers out front and leave it times 10 to the 22nd power. So I'm going to go ahead and subtract 597 minus 7.35 here. And when I do this, I'm going to have to do some borrowing here. I end up with 589.65 times 10 to the 22nd power. Okay, now this is not in scientific form, scientific notation, so I need to move this decimal back 2 more places. So essentially, because I'm taking away some place values here, I need to add the place values that I took away back onto my powers of 10. So I'm going to end up with 5.8965 times 10 to the 24th. You'll notice that we got the same answer here as we did doing option 1, but it took a little bit less work. I know there's some trouble that comes with this part, you know, moving the decimal, but it takes a lot less time to do it this way than it does to have to write those numbers out. This works for both addition and subtraction. So the only difference is if we were doing an addition problem, I would just be adding those 2 numbers out front there. Okay. The second example is what to do when you are multiplying numbers in scientific notation. Multiplication and division with scientific notation, I think it's a little easier than adding and subtracting. You don't get the decimal place as messed up here. So for this one, the Confederation Bridge connects New Brunswick to Prince Edward Island. The main part of the bridge rests on the piers that form 43 segments. What is the approximate length of the main part of the bridge? Express your answer in scientific notation. So essentially we have these distances and we have 43 segments of them. So I want to know how many total distance it is, how much the total distance is. So I'm going to be taking 8.2 times 10 to the 2nd power and multiplying that by 43. Okay, so for this, you need to express both of them in scientific notation. It doesn't matter if they have the same power, but they both need to be in scientific notation. So for this, I'm going to rewrite 43 in scientific notation by putting a decimal point here. So times 4.3 times 10 to the first power, because we only would need to move it one time to the right to get back to 43. And then when you have all of these multiplications happening, we can use the associative property and move around, or sorry, the commutative property and move around our numbers so that we're multiplying the decimals together and we're multiplying the tens together. So I can rewrite this as 8.2 times 4.3 times 10 squared times 10 to the first power. I'm going to multiply 8.2 times 4.3. Again, we don't get calculators for this, so I'm going to have to do this multiplication by hand. I'm going to go ahead and pause this while I work this out. Okay, I ended up with 35.26 for that multiplication, and then I'm going to multiply that. When you multiply the same bases, remember you add the exponents, so 2 plus 1 would be 10 to the third power. And finally, we want to put our answer in scientific notation like the directions stated. So I need to move this decimal back one place. So if I'm taking away a place value, remember you need to add that place value that you took away onto your powers of 10. So for this, our answer would be 3.526 times 10 to the fourth power. All right, so that's multiplication. Now we're going to do a division problem. So the queen ant lays 1.83 times 10 to the sixth eggs over a period of 30 days. Assuming she lays the same number of eggs each day, how many eggs does she lay in one day? So we need to divide the total eggs by how many days to get her rate per day. So I have 1.83 times 10 to the sixth. We're going to be dividing it by 30. Again, we need to write this in scientific notation. So I would have 1.83 times 10 to the sixth divided by 3 times 10 to the first power, because I would just be moving this over one time. You're going to rewrite division as a fraction, so we can easily divide this out. Okay. Just like we did above, you're going to divide your front numbers here. So I'm going to be dividing 1.8 times 3, sorry, 1.8 divided by 3, and then my 10 to the sixth divided by 10. So I'm going to go ahead and do this first division here. So I'm going to pause this. All right, when I divided, I ended up getting 0.61. So this, I'm just going to bring down what I divided. And then times 10, when you're dividing same powers, sorry, same base to different powers, you subtract the powers, so 6 minus 1, which is 5. And finally, this is not in scientific notation because it's less than 1, so I need to rewrite this. So for this one, I'm adding a place value. I'm moving my decimal point to the right one, so I'm actually going to have to take away one of my powers of 10. So whenever you're adding a place value, you have to take away that place value from your powers of 10. So for this one, our answer is going to be 6.1 times 10 to the fourth. That's about how many eggs she would lay in one day. All right, that's all for lesson 110, and that's all for chapter 1. So the next thing you'll be seeing is the review for the test, so be looking out for that video.